Hello friends, welcome to Learner's Planet. Friends, the fourth session for problems on triangles and other polygons. We have been doing so many problems for last three sessions, and you must be getting the confidence on triangles and other polygons. And let's take some more problems in this session. Get ready with your paper and pen and do attempt the question on your own before you watch the explanation. Okay, let's begin. Let's see this question. In the figure, E and F are midpoints of AB and AC respectively. G and H are points on BD and CD respectively, such that this is if EF is equal to 6, then GH is equal to. Okay, so what I do, first of all, I join B and C. Now going to be very interesting problem. Just listen to me carefully. See, DG by GB is equal to DH by HC. DG by GB is equal to DH by HC. That means the triangle DGH and DBC are similar because sides are in proportion. Or we can say this is Thell's theorem, right? DG by GB is equal to DH by HC. This is Thell's theorem, and if we expand Thell's theorem, we can say that the triangles are similar, right? So triangle DGH and triangle DBC, they are similar triangles, right? So this is 3, this is 5, then this is also 3, this is also 5. 3:5 ratio is there, so I assume this to be 3x, this is 5x, this is 3y, 5y. Okay. Now since the triangles are similar, DG by DB is equal to HG by CB. So DG is equal to 3x and DB is equal to 8x. So the ratio of this and this should be 3:8, right? So this is 3z and this is 8z. Okay. So do not get confused. GB is 5, but the complete length DB is 8 part, right? And triangle DGH is similar to DBC. So corresponding sides will be 3x and 8x. So it is 3z and 8z. Now, an application of midpoint theorem has been used over here. In triangle ABC, see, this E is the midpoint of AB and F is the midpoint of AC. So in triangle ABC, EF will be parallel to BC and length of EF will be half than that of BC. Okay, so since EF is equal to 6, BC should be double of 6, that means 12. So 8Z is equal to 12. So Z is equal to 12 by 8, or I can say 4 3s and 4 2s, 3 by 2. Okay, now we have to find out GH. GH is what? 3z. So 3z, 3 into 3 by 2, that is 9 by 2, or I can say 4.5. So concept of similar triangles as well as midpoint theorem we have used over here. And the important point over here is when you take DG is to GB, that means but precisely the triangle DGH is similar to DBC. So do not forget to take the complete length, right? DG is 3x, GB is 5x, so complete DB will be 8x. That's why this is 8x, that's why we are taking this as 8z and this as 3z. And this variable should always be different when you are taking the sides in proportion, because if it is 3x, it will be multiple of 3, but not necessary that the same length will be there. So if it is x, it is y, it should be z. All of them should be having different variables. Okay, HCF should be 3, but variables must be different. So that's an important concept. I hope you are clear. Now let's see this problem. In the figure ABCD, E is a regular pentagon. Find angle AFD. Okay, that is this marked angle we have to find out. Now in a regular pentagon, each angle is of 108 degree, right? That means this is 108, this is 108. Now BC is equal to BA because it is a regular pentagon. That means in triangle BCA, this angle will be equal to this angle, right? Now this is 108, that means this plus this must be 72, that means each of them must be 36. Now if this angle is 36, this must be 108 minus 36, that is 72. Similarly, this angle should also be 72, 72, 72, 108, and out of 360 if we deduct all these three, because A, F, D, E, it's a quadrilateral, right? So sum of all the four angles must be 360 degree. So from 360, if I deduct 108, I deduct 144, I'll be able to get angle F. So that is 108. Okay, pretty simple. Now let's see this problem. According to the figure, which of the following must be true? Now here this line is given to be parallel to this line. So what I do to make the problem simple, I just draw a parallel line from this vertex also. So that's the line. Okay, now this line is parallel to this line and parallel to this line. Now we'll be using the basic properties of parallel lines. Okay, so this, I suppose this angle to be X, this Y, Z, and this is P. Okay, now you can see X and Y, these are interior opposite angles, so X plus Y must be 180. Similarly, Z plus P should be 180. And B plus Y plus Z, that should be 360 because that is center angle. So B plus Y plus Z is 360. Now from here we can see this is also a center angle, so X is actually 180 minus A. Since we want the relationship in A, B and C, X can be written as 180 minus A. So it is 180 minus A plus Y is equal to 180, right? X plus Y 180, and instead of X I am writing down, this is 360 minus A, 360 center angle, so it is 360 minus A plus Y is equal to 180, right? So A, we can calculate Y in terms of A, so Y will be equal to A minus 180. Now instead of Y we can put up this value. B we already have. Now we want the value of Z. So in terms of A, B and C. Now P plus Z, that is 180, but P is what? 360 minus C, same as over here. So it is 360 minus C plus P is equal to 180. Okay, so P is equal to C minus 180. Okay, now you got P, now you got Y, so and B you already have over here, so just put up the value of I made a mistake. P is actually 360 minus C, so it must be Z over here. So this is Z. Z plus P is 180. Instead of P I am writing down 360 minus C, so this is Z is equal to 180. So Z is equal to C minus 180. So B plus, instead of Y, A minus 180, instead of Z, C minus 180 is equal to 360. Okay, so what we are getting, A plus B plus C is equal to 720. Okay, so I hope it's clear to you. Now see this. In the figure, AB is parallel to CD and AC is equal to BD. If CAD is equal to 20 and ADB is this, then ADC we have to find out. ADC, that means this angle, I suppose it to be X. Now if it is X, it has to be X. Now since AC is equal to DB, 20 plus X, this angle will also be 20 plus X. Okay, and I suppose this angle to be Y. So X plus Y must be 160, and this is X, this is X. I suppose this to be Z. Then x plus z to be 100. Okay, because x plus z plus 80, it should be 180. Now z is equal to 20 plus x. So instead of z I write 20 plus x. So x plus 20 plus x is 100. So 2x is 100. I'm sorry, 80. So x is equal to 40. Right? Pretty simple. Now we see this problem. In the figure, ABCD is a parallelogram. M is a point lying on BC such that BM is to MC is 1:2. If BD and AM intersect at G, area of BGM is 1 centimeter square, then area of parallelogram ABCD is. Okay. Quite an interesting problem. Here it is M. BM is to MC is 1:2. So suppose this is X, then this must be 2x. Now this is 3x, so it has to be 3x, right? And as always, BGM and AGT, these two are similar triangles, right? So if there are similar triangles, their area will be in the ratio of square of their corresponding sides. So its side is x and here it is 3x, right? So area of BGM, if it is 1, then area of AGD will be 3 square, that is 9. Okay. Now since we have to find out the area of the parallelogram ABCD, we have area of AGD and BGM, but we don't have area of BGA, right? See, this BD, it divides the parallelogram into two equal area, right? So if we are able to find out the area of ABD, we'll double it, then we'll be able to get the area of the entire parallelogram, right? So for that we need to have the area of this. Okay, now how do we find out the area of this? For that, suppose I draw an altitude over here, right? This is altitude and this is altitude for this triangle, right? Now altitude will also maintain the same ratio. So suppose it is L, it has to be 3L, right? Then area of triangle BGM, that will be what? Half LX, right? Half base into altitude. So half XL, and that is actually 1, right? That's already given. That means LX is equal to 2. And similarly, what will be the area of triangle ABD? See, altitude of ABD will also be same. That is this L plus 3L, 4L. So half into 4L, and base of triangle ABD is AD, that is 3x, right? So it is actually 6LX, that is area of triangle ABD. The value of LX is 2, so 6LX will be 12. That will be area of triangle ABD. So if we double it, we'll be able to get the area of triangle BDC, or precisely area of the parallelogram ABCD. So that's 24. Okay. So very simple problem based on the concept of similar triangles. Okay. So when the two triangles are similar, their sides are in ratio, their altitudes are also in the same ratio. That concept we have used over here, right? Next one. In the figure, the rectangle ABCD is divided into 8 identical rectangles. Find the area of rectangle ABCD. Pretty simple problem. You hardly need paperwork to solve this problem. See, this BC has been given as 8, right? Now, see this rectangle, this and this. We have to find these two. Now here, 1, 2, 3 and this 4. Right, this 8 is broken up into 4 equal parts, right? 1, 2, this second, third and 4. That means this each one of them is 2, because all the rectangles are identical. That's mean their breadth will be equal. So each one of them is 2, right? So this is 2, this is 2, this is 2, this is 2. Okay. And again, just see here. this is 2, this is 2, and this is 2. That is nothing but length of this rectangle, right? So 2 plus 4 2 plus 2 4, 4 plus 2 6. So this is 6 and this is 2, right? For this particular rectangle, if we talk about, this is 6 and this is 2, right? So area of one rectangle is 6 into 2, 12. Now we have similar 8 rectangles. So 6 into 2, 12 into 8, 96 will be your answer. Okay, pretty simple. Now let's see this one. In the figure, ABCD is a parallelogram. E is a point lying on AB. If EC and BD intersect at F, then ratio of area of DEF and to area of CBF. DEF, that means area of this triangle, and CBF, area of this triangle and this triangle. Okay, now once again we'll be using the concept of similarity. Over here, triangle EFB and triangle DFC, both of them are similar to each other. Now assume this to be A and this to be B, right? This length AE is A and EP is B. That means this total length is A plus B. That is the total length of this triangle, that is DFC. Okay, now as I've already told you, DFC and EFB, they are similar triangles, right? And I don't have to give you the explanation why they are similar. Now since side ratio of these two triangles is B and A plus B, altitude will also be in the same ratio, right? So this is suppose BX, this will be A plus B X, right? This altitude and this altitude. So the total altitude of this parallelogram will be A plus 2B X. Okay. Now area of triangle DEC will be half base into altitude. So it is half A plus B into altitude, that is A plus 2B X. Minus area of triangle DFC, because we just want this area. So DFC area will be half A plus B, that is base into altitude is just A plus BX. Okay, so this is the area of DEF, and similarly we can find out the area of EFB. Here triangle ECB area will be half B into altitude, that is A plus 2BX, minus half area of this triangle, that is half base into altitude, that is BX. Okay, now you can take half as common and delete it. X can also be deleted. From numerator, if we take A plus B as common, then we'll be left with A plus 2B minus A minus B, right? So A plus 2B minus A minus B, so it will be just B. Okay, and in the denominator we can take B as common, so in the bracket A plus 2B minus B, so it will be just A plus B. So that's 1:1 ratio. So that's pretty simple. We need to take the variables over here because we don't know the ratio of AE and EB, right? If ratio of AE and EB is given, then the problem becomes very simple, because in that case we don't have to deal with the variables, right? But when it's not given, you need to choose the variable, because you cannot imagine the ratio over here, because if the ratio of A and B changes, then the entire calculation will be changed, right? If instead of E over here, if it goes to right hand side or left hand side, the ratio will be changed. Okay, so be careful about it. Do not assume the values in such cases. In the figure, the area of trapezium ABCD is ABCD is. Okay, now to be able to find out the area of trapezium, what we need some the dimensions of the parallel sides as well as distance between them, right? So here we have AB as 38 centimeter, but we don't have DC. Now DC can be calculated very easily because ADC is a right angle triangle where AD is also given and AC is also given. So it is 15, it is 17. Now you know the combination of 8, 15, 17 Pythagorean triplet, right? So if it is 15, it is 17, it has to be 8, right? So DC is equal to 8. Now what is the formula for area of the trapezium is half sum of parallel sides, that is 38 plus 8, 46, into distance between them, that is 15. Okay, so it is 23 into 15. So unit digit must be 5, so we just have one option over here with unit digit 5. So do not multiply the entire number. Okay, I hope you are clear. Now this problem, in the figure ABCD is a parallelogram. EFG are points laying on BC, CD and D respectively. AE and AF divide BAT into 3 equal parts, and BG bisects ABC. If AE and AF intersect BG at H and I respectively, then GIF. Precisely diagram is already given, so you don't have to read the entire story and get confused. So let's start. Now since it is given that AF divide BAD into 3 equal parts, right? So BAD, AE and AF divide 3 equal parts. So this is, suppose X, this will also be X, this will also be X. Similarly BG bisects this angle, so if it is Y, it is Y, right? I assume this to be Z, then this will also be Z, vertically opposite angle. And this I suppose A, then this will also be A, being vertically opposite angle. Now we wish to have the calculation, that is A plus Z is equal to what, right? Now in a parallelogram, this plus this, right, sum of interior angles, it should be 180. So precisely 3x plus 2y is 180. Okay, and apart from that we have triangle XYZ, that is also 180. So these two will be equal. So I can say X 2x plus y is equal to Z. And from here we can see Z is equal to A plus X. It is an exterior angle, so that will be equal to sum of interior opposite angles. So it is Z is equal to A plus X. So Z is equal to A plus X. So I can say X plus Y is equal to A. Now we have to find out A plus Z. A we have already got. I add Z both the sides. So X plus Y plus Z is equal to A plus Z. So precisely A plus Z is nothing but X plus Y plus Z, and X plus Y plus Z is nothing but 180 degree, being the angles of triangles, right? So that's this. Okay, pretty simple. In the figure, ACE and BDF are straight lines. If the areas of quadrilaterals ABDC and CDFE are 16 and 5, ABDC and CDFE is 16 and 5, then the length of AB is. Okay, good problem. Try it. Here what we can do is, this problem can also be solved using similar triangle concept. Now you may not be able to see the triangle over here, so to make it a triangle, what I can do is I can extend this, right? Treat it as a straight line because I'm not able to draw to scale, and similarly from this side also I can extend it. Okay, now suppose this point is a P. Okay, now PEF, PCD and PAB, all of them are similar triangles. Now if the triangles are similar, you know what will be their area? Their areas will be in the ratio of square of their corresponding sides, right? So I assume AB is X. Okay, so area of triangle PEF and area of triangle PCD, since both of them are similar, their area will be in the ratio of square of their side. So I know one side of PEF and one side of PCD. So that's 3, 2 and 3, right? Corresponding sides are 2 and 3. So area of PEF will be 4 K, I suppose, and area of PCD will be 9K, right? So area of see this ECDF will be 5K, right? Because see, this complete area is 9K. Out of this, if we deduct the area of this triangle PEF, then we are left with 5K. Okay, so area of CEFT, that is this trapezium or quadrilateral. Over here the word quadrilateral has been used. So area of ECDF is 5K, right? And we have been given the area of CDFE, that is 5. So 5K is equal to 5, that means K is equal to 1. That means area of this is 4, area of this is, this entire triangle CPD is 9. Okay. Now similarly, area of ABDC is 16, right? ABDC is 16. Now see, be careful, this is 4 part, this is 5 part, this is 4, this complete is 9, and only this portion is 16. So the complete area of APB will be 25, right? Just be very careful. This is 4. This complete portion is 9 because that was 9K, being K is equal to 1. But 5 is only this portion, right? So this is 4. This area is 4. This is 5. And only this area is 16. Okay. So the area of total triangle is 25, right? Now area of triangle is 25. That means side is 5. Okay, the same reason area is in the proportion of side of square of side. Okay, so it's 5. So it was pretty interesting question. Not much paperwork is required, but you need to be clear with the similar triangle concept, right? So when you have this sort of problems, if you don't see the triangle, in case of trapezium also this funda will be used, right? You just have to extend the sides. So you get a beautiful triangle, right? And after that, okay, so that was pretty simple, and I hope you are clear also. Now let's try this problem. In the figure, value of x we have to find out. Once again, see what we can do to make the problem simple is we draw a line parallel to these two lines, right? After that the problem will be very easy. Okay. See, if it is 130, it has to be 50. Reason, sum of interior opposite angle is 180 degree. And then this and this, they should also be 180. So if it is 120, it has to be 60. Now this 3, they are also forming a linear pair. So this plus this again they should be 180. So x plus 110 is 180. That means x has to be 70, right? Pretty simple. So whenever you see this sort of problems, when an external angle is asked, then just draw a line parallel to these two lines, the given two lines. Okay, then the problem will be very easy for you. Now this problem. In the figure, ABCD is a rhombus and CDE is an equilateral triangle. If ADE is a straight line, then area of quadrilateral ABCE. ABCE, we have to find out the area of this quadrilateral. Precisely, it is a trapezium. Now this is an equilateral triangle, and if it is 2 centimeter, it has to be 2. It has to be 2. Now since ABCD is a rhombus, rhombus has all the sides equal, so if it is 2 centimeter, it has to be 2 centimeter. Being equilateral triangle, this is 60 degree, that means it has to be 120 degree. Now the game is very easy for us. You just find out the area of this triangle ADC, and double of that will be area of ABCD. Then you easily you can find out the area of this equilateral triangle, right? So how do we find out the area of this triangle? We can directly use sine formula, right? So half sine 120 degree. Sine 120 is cos 30 is root 3 by 2. Okay, so half sine 120, this into this, 2 into 2, right? So this is the area of triangle ADC. Double of that will be area of this rhombus, plus area of this equilateral triangle is root 3 by 4 into side square. Side is 2, so it is 4. So this is precisely the area of ABCE. Okay, it's 4, 4. So this is 2 root 3 plus root 3, in all it is 3 root 3. Pretty simple. And once again, just remember sine formula. Now see this problem. In the figure, ABCD is a parallelogram and E is the point on AD such that AE is equal to ED is 1:3. If the area of ABE is 3 centimeter square, then the area of the shaded region is, okay, ABE is a triangle with area 3 centimeter square. Now just listen to me carefully. Very simple question. If, see, I just draw this line over here. Okay, now this AE, this is a triangle, and how can I draw this triangle over here? Like this. Now see, suppose this is, I just write it, A, E, D, C, B. This is actually one part and this is 3 part. Okay, now AEBP, it is also a parallelogram, right? AEBP, that is also a parallelogram, and the base of this is 1/4 of the entire parallelogram, right? The base of the entire parallelogram, the original parallelogram is 4 part, and base of this is 1 part, so it is actually 1/4 of the original parallelogram, right? That means area of this parallelogram, that is ABPE, area of ABPE will be 1/4 of ADCB. Am I right? Okay. Now, if any parallelogram we have, diagonal divides the parallelogram into 2 equal triangles, right? That means this triangle and this triangle, both of them are equal in area. Now we have been given ABE area is 1. So if this is area 1, then this has to be area 1. That means parallelogram ABEP is having area S2, and if it is having area S2, the entire parallelogram will be having the area as 8, right? That means PEDC must be having the area as 6. Okay, 6, 7, 8. Area of ABPE is 1/4 of ABCD, right? Because base is 1/4, that's why area is 1/4, because altitude is same. And the second concept, diagonal divides a parallelogram into 2 equal triangles. So if it is 1, it has to be 1. Now we want the area of the shaded region. Now do I need to tell you? This is 1 part, this is 1 part, this is 6 part. So shaded region is 1 plus 6, 7 part. Okay. Now I assume this area to be 1 part, this to, then it is 1 part. In all it is 7 part. Now 1 part is practically 3, that's given over here. So 7 part must be 21. Okay. So you can see hardly any paperwork is required, right? And if you are conceptually clear, you don't have to draw even the diagram, right? You just visualize from this point to this point. If you draw a line, then AEPE, that is 1/4 of the entire parallelogram. So its area will be 1/4 of the entire parallelogram. After that, the diagonal divides the parallelogram into 2 equal triangles. So if it is 1 part, it has to be 1 part. If it is 3, it has to be 3. So 3 and 3, 6 is the area of ABPE. That means entire area must be 24. That means if from 24, if we deduct ABE area, that is 3, you'll be left with 21. That is the area of the shaded region. Okay, very simple. And why it is happening? Because altitude is same, right? So if in any question, if you get a line that divides the parallelogram into 1:1 ratio, that means area of this is equal to area of this, right? If it divides into 2:3 ratio, the same thing you have to do, because in all these cases altitude is same, right? Now in this problem, in the figure, ABCD is a parallelogram and ADH, EBC, EFGH are straight lines. If AD is equal to 6, DH is equal to 4 and EB is to BC is 3:4, then EF is to GH. Quite interesting problem. See here, EB is to BC is 3:4. So EB is to BC is 3:4. So suppose this is 3x, then this is 4x. Right? Now triangle EFB and triangle EGC, they are similar triangles because FB is parallel to GC. So this angle will be equal to this angle and this angle will be equal to this angle. So it is AA similarity, right? If the two triangles are similar to each other, then their corresponding sides will be in ratio. Okay, and so if and apart from that, we can apply basic proportionality theorem also. I just go for a quick recap. See ABC, and here DE, if it is parallel to BC, then AE by EC will be equal to AD by DB. AE by EC is equal to AD by DB, right? That is basic proportionality theorem. Okay, so that's pretty simple. To apply, EB by BC is equal to 3x by EB 3:4. So this ratio EF is to FG will also be 3:4. But be very clear that the constant, then the exact value may not be same, right? If it is 3x, 4x, you need to choose other multiple. So I take this is 3a and this is 4a, right? It may be 3x, but it will be 3a. Be very clear about it. Do not choose the same common multiple. Okay, maybe this is 6 because 4x is already given, that is 6. So this is 6 and this is 4.5. So length of EF and FG may be different. Okay, so we just can take 3a and 4a. So the ratio can be maintained, that is 3:4, right? Now similar concept will apply over here in this HDG and HAF. Right, again this line is parallel to this line, so basic proportionality theorem can be applied. So HD is to DA will be equal to HG is to GF, right? Now HD is to DA is 2:3, so HG by GF will also be in ratio 2:3. Okay, but now variable will be once again different. So I take this as 2k, so then it will be 3k. Okay. So from this point to this point, earlier we took 4a, now we are taking 3k. That means precisely 4a is equal to 3k. So a by k is equal to 3 by 4, right? But we want the ratio EF is to GH. EF is what? 3a. GH is what? 2k. That means 3 by 2 into a by k, and what is a by k? That is 3 by 4. So 3 by 2 into 3 by 4, it is 9 by 8. That is 9:8, right? So no much paperwork is required. If you know this theorem, hardly this much paperwork is required, right? So the problem can be done in seconds if you know the concept of basic proportionality theorem and similar triangles, right? I hope you are clear. Now see this, in the figure ABCD and PQRS are two rectangles of equal perimeter. Here AB is to BC is 3:2 and PQ is to QR is 4:3. Area of ABCD is to area of PQRS. Okay, so that's pretty simple. Here AB is to BC is 3:2. So I assume the dimensions to be 3x and 2x, right? So area will be 3x into 2x, and here in this case area will be 4y into 3y, right? Now we know perimeter of these two are equal, is equal precisely. So this is the perimeter is what? 3x plus 2x into 2. So precisely it is 10x, or I just can take half of that also. So 5x is equal to 7y. That means x by y is equal to 7 by 5, right? X by y is equal to 7 by 5. Now the ratio of area is what? 6. I just cancel this. So it is 1 upon 2 x square by y square, right? So x by y is 7 by 5, so x square by y square is 49 by 25. Okay, so it is 49 by 50. Pretty simple. Now this problem, in the figure AEDC is a parallelogram, AB is to BC is 1 is to 2 and AF is to FE is 2 is to 1. Then area of ABF and area of BCD, we want a ratio. Okay, now the problem can be done very easily using sine formula. The only thing you must be knowing is the relationship between this angle and this angle, right? If this is theta, then it is 180 minus theta. Okay, now AF and AB, BC and CD we know, all of them. AB is to BC is 1 is to 2, so if it is x, this is 2x. AF is to F is 2 is to 1, so if it is 2A, this is A. So AE is 3A, that means CD will also be of 3A. Now the story is very simple. We want the ratio of area of triangle AFB, that is ABF and BCD. Okay, so what is the area of triangle AFB? That is using sine formula, half sine theta into these two sides, right? Product of these two sides and sine of included angle, right? So it is half sine theta x into 2a. Okay, that is the area of triangle ABF. ABF, half product of the sides and sine of included angle. So half 2a into x into sine theta, and area of this will be half sine 180 minus theta. Included angle over here is 180 minus theta, so it will be sine 180 minus theta. Now sine 180 minus theta, if you know, it is only sine theta. Okay, but knowledge of trigonometry is required, so you can solve the problem in just seconds. Okay, otherwise it will be time consuming process. So sine 180 minus theta is nothing but sine theta, okay, into product of the sides, so that is 2x into 3a. Okay, sine theta cancel, half cancelled, a and a is cancelled, x and x is cancelled, 2 and 2 is cancelled. You are left with 1 is to 3. So the problem can be done in seconds if you know the sine formula and if you know this logic, that is sum of interior angles of the parallelogram is 180 degree, right? This or you can say adjacent angle, sum of adjacent angle should be 180 degree. Right? Sine 180 minus theta is sine theta, that you must be knowing. Okay, I hope you are clear. So friends, a good number of problems we have done in this session, and you might have observed that most of the sums are based on the concept of similar triangles, right? So the basics of similar triangles must be very clear with you, very clear to you, and whenever you see the triangle like this, and you see a line parallel to the base, then this original triangle and this triangle, both the triangle, this small triangle and this bigger triangle, both of them will be similar, right? So this funda you should be knowing, and your time should not be wasted in this. Okay, and apart from that, basic proportionality theorem, if this line is parallel to this line, then this by this is equal to this by this. Okay, so that should be clear in your mind. Once this thing is clear, I think 90% of the problems from similar triangles will be very easy for you, right? So I'll take more problems, we'll discuss more problems in our coming sessions. Do revise this session and the basic session of triangles, quadrilaterals and other polygons. Bye bye.